Hello everyone. Let's start today's session with a simple question. Have you ever tried drawing water from a well using a rope and a pulley? Or watched a crane lifting giant loads at a construction site? What makes all of this possible is the pulley, one of the simplest yet most powerful machines. A pulley consists of a grooved wheel with a rope passing over it. By changing the direction of effort or reducing the force required, it makes lifting heavy objects much easier. From wells and elevators to shipyards and gym equipment, pulleys are everywhere around us. Today, let's dive into their principle, types, and applications. Now, how do pulleys actually work? A pulley works on the principle of transmitting force through a rope. When you pull at one end of the rope, the force is transferred to the load at the other end. For an ideal rope, which we assume to be weightless and inextensible, the tension throughout the rope is uniform. The input work is the effort multiplied by the distance moved by the effort. The output work is the load multiplied by the distance moved by the load. So in words, the formula is work output equals load multiplied by load distance and work input equals effort multiplied by effort distance. As you can see in the diagram, the effort applied at one side gets transmitted through the rope to lift the load on the other side. Let's begin with the simplest type, the single fixed pulley. Here, the pulley is fixed to a rigid support. It allows you to pull downwards to lift a load upwards. This means it only changes the direction of the effort, not its magnitude. For an ideal fixed pulley, mechanical advantage equals 1, velocity ratio equals 1, and efficiency equals 100%. An everyday example is using a pulley to draw water from a well. As shown in the diagram, when you pull the rope down with a certain effort, the load moves up by the same amount. Now let's look at the single movable pulley. In this case, the pulley itself is attached to the load and moves along with it. The effort is applied on one end of the rope, while the other end is fixed. Because the load is supported by two segments of the rope, the effort required is held. Here, the formulas are mechanical advantage equals 2, velocity ratio equals 2, and efficiency equals mechanical advantage divided by velocity ratio multiplied by 100%. You often see this in construction sites, where movable pulleys are used to lift heavy blocks with less effort. As the diagram shows, the load is supported equally by two rope segments, reducing the required effort. Things get even more interesting when pulleys are combined to form a block and tackle system. In this arrangement, one block of pulleys is fixed and the other block is movable. The effort is applied by pulling the rope, which passes alternately over pulleys in the two blocks. In this case, the velocity ratio equals the number of strands of rope directly supporting the load. So in words, the formula is velocity ratio equals n, where n is the number of supporting strands. This kind of system is used where extremely heavy loads need to be lifted, such as in cranes, shipyards, or large workshops. As you can see in the block and tackle diagram, the more pulleys and rope segments we add, the smaller the effort required. Now let's solve a numerical problem together. A block and tackle system has 4 pulleys in total. It is used to lift a load of 800 newtons with an applied effort of 250 newtons. We need to calculate the mechanical advantage, velocity ratio, and efficiency. Step 1. Velocity ratio equals n, which is the number of supporting strands. Here, n equals 4. So we are equals 4. Step 2. Mechanical advantage equals load divided by effort. That is 800 divided by 250, which equals 3.2. Step 3. Efficiency equals mechanical advantage divided by velocity ratio multiplied by 100%. Substituting values, we get 3.2 divided by 4, multiplied by 100%, which equals 80%. So the final answers are velocity ratio equals 4, mechanical advantage equals 3.2, and efficiency equals 80%. This means the pulley system reduces the required effort significantly, but due to losses, the efficiency is less than 100%. Let's quickly revise what we've learned. A pulley is a simple machine that helps us lift or move heavy loads using a rope and a wheel. The single fixed pulley changes only the direction of effort. The single movable pulley reduces the effort needed by half. The block and tackle system is a combination where velocity ratio equals the number of supporting strands, making it ideal for lifting very heavy loads. Real-life applications of pulleys are everywhere, from wells and elevators to cranes and gym machines. So, pulleys beautifully show us how simple machines can multiply our ability to work. I hope you now have a clear understanding of pulleys and their importance in daily life. See you in the next session with another exciting concept in physics.